More examples of U-substitution. So number 3 is the integral of tangent x dx. And of course, this is not one of our fundamental antiderivative rules. But of course, we can write tangent x as sine x over cosine x dx. And what's tricky about this is that we can put this in the form of a du over u, which is the form that integrates to log u. So whenever you have a ratio, you might consider what happens if you pick the denominator equaling u. So suppose we pick the denominator equals cosine x. Well, then du equals negative sine x dx. So we need a negative sign. We'll put a negative inside and outside, but then this entire sine x dx simply becomes du. And so what we get is negative du over u, which is negative log u plus c. And this is negative log cosine x plus c. And of course, we can bring the negative inside the logarithm, where it becomes a power of -1, so that becomes 1 over, and 1 over cosine is secant. And so what this is the log of secant plus c. And that, in fact, is the antiderivative of tangent x. Another one, also of this same form, integral of x dx over 1 plus x squared. Again, we'll try u equals 1 plus x squared. U equals the denominator. Then du equals 2x dx. So we need a factor of 2 inside, a 1/2 outside. So we get a 1/2 integral of du over u. And this is 1/2 of log of absolute value of u plus c. So 1/2 log of 1 plus x squared plus c. Now notice something very interesting here. Notice that the integral of x dx, we just found the integral of x dx over 1 plus x squared, is 1/2 log of 1 plus x squared plus c. But notice that we didn't have that x in the numerator if it were just dx over 1 plus x squared. This integrates to arctangent or inverse tangent plus c, which is a completely different category of functions. So notice just one factor of x in the numerator makes a wild difference in how we integrate the function. So something to be very mindful of when we're using U substitutions.